On this number 4 here, we're being asked about what transformations are used to get the graph of one function from the other. So g is the resulting function and f is the OG original absolute value function that you need to describe the transformations from. You don't have to graph the functions in this question, but I'll speak a little bit about how the transformations work so you understand. So I always start, the sequence of transformations is sometimes important. The order in which they show up is important. So you always start with whatever happens first. And think about it. If you were to plug in x equal to 1 into g, what do you do with it first, right? So let's say x equals 1. The first thing you do is you add 1 with 4. So that is the first transformation I need to describe, because that's the one that I do first to x. Okay? So the first transformation, whenever I add x and I add 4 to x nearby x, I move 4 units, so that's a shift of 4 units to the left. So it isn't the horizontal because I'm doing it to x, not to the result of some operation, right? I'm doing it before taking the absolute value, and the absolute value is what's marking the original function. So if I'm doing it before, then it's happening to x, so it's in the horizontal, either left or right. But it is being done to the left because whenever you do this type of transformation to x, it is counterintuitive. We talked about this in class, but the idea is that what would you have to do? Let's say absolute value x plus 4. Give you 2 examples so you understand. Let's say f of x, absolute value x, and then g of x is absolute value x plus 4. So what is f of, let's say, 2, right? That's absolute value 2, which is 2. And now the question I'm asking is, what x do I need on g to get the same 2 I got on f, right? So absolute value, so let's say if I do g of 2, I'm not going to get 2 back. I'm going to get 2 plus 4, which is 6. So if I want that 2 as a result, I need to change the x I use. So to change that x I use, if I'm adding 4, I have to subtract 4 here to compensate. So that's minus 2, right? And g of minus 2 is absolute value of minus 2 plus 4, which is absolute value 2, which is 2. Okay, so I gotta subtract 4 from the 2, so that when I add the 4 back, I'm back where I started. So this is pretty important. So this is the idea. You don't have to write any of this in this type of question, but it's a good thing to have in mind when you're solving these questions, to understand why anything that happens to x is counterintuitive. So this plus 4 is taken care of. Next you have, so you take the absolute value then, and after that you multiply by negative 2. So that is 2 things at once. That is a stretch up by a factor of 2 and a vertical stretch, right? Because you're multiplying after the absolute value. So you take the result of the absolute value and you double it by a factor of 2, right? 2. And then the negative sign means a reflection. Also vertical because it's happening outside of the absolute value. So it is a reflection across the x-axis. Right? The x-axis is the horizontal one, but when you reflect across it, your reflection is vertical. Okay, you take something here on the top, it ends up at the bottom. So it is a vertical reflection. These two are the only ones that can be interchanged because they're happening at the same time, right? It's minus 2 and minus 1. It's the multiplication. The order doesn't matter. And then the last transformation that we need to take care of is this plus 1 outside. So it is a shift of 1 unit upward. So that's the plus 1 outside. Again, it's upward because it's happening outside of the absolute value. Anything that happens inside of the original absolute value function is left or right, or horizontal stretch or shrink. Anything that happens outside is up or down, or vertical stretch or shrink.